Let's review some of the proofs, or excuse me, postulates and theorems that we talked about so far in this chapter. I know it's been a long weekend. So, remember the first ones we learned dealt with parallel lines. And it said if two lines are cut by a transversal, oh wait, I gotta back up. If two parallel lines are cut by a transversal, then what do we know about the corresponding angles? They're congruent. If two parallel lines are cut by a transversal, what do we know about the alternate interior and alternate exterior, or sorry, alternate exterior angles and the alternate interior angles? Like 1 and 7 and 3 and 4. Congruent, right? So if two parallel lines are cut, so if two parallel lines are cut by a transversal, and that's the big key here, right? And then if two parallel lines are cut by a transversal, what do we know about the consecutive interior angles? What is that? Supplementary. Yeah, supplementary. Okay. I'm asking these questions, and I expect you all to answer the questions. Some of you are mumbling. Some of you are letting other people mumble. Let's hear it. Okay? So, that's the first set of theorems that we talked about. The second set is related, of course, but it's the converse of each one. So I have these two lines. I don't know if they're parallel or not. But let's say angle 1 and angle 5 are congruent. So I have two lines cut by a transversal and the corresponding angles are congruent. What do you guys know about the two lines then? They have to be parallel. Good. They have to be parallel. I have two lines cut by a transversal and the alternate interior angles are congruent. What do we know? The two lines are parallel. I still hear mumbling and some of you not saying anything. Come on. And two lines are cut by a transversal and the alternate exterior angles are congruent. Then what? All right. And then that was more mumbling. And then, these consecutive interior angles. They're the ones that are different, aren't they? They're not congruent. Their sum's going to be 180. If their sum is 180, then the two lines are. Oh, good. Okay, then the two lines are parallel. Remember, 4 and 3 are not consecutive interior angles. Even though they're on the interior and they are adjacent to one another, we don't call them consecutive interior angles because they're on opposite sides of the transversal. Consecutive interior angles are always on the same side of the transversal. Okay? And it wouldn't do you any good. Like, for example, if I knew 4 and 3 were supplementary, well, first of all, aren't they a linear pair? And aren't all linear pairs supplementary? Of course they're supplementary. But that's not going to tell you anything about these two lines being parallel, is it? Because you don't have any knowledge about a relationship between both intersections, do you? Okay? So, there you go. So today we're going to talk more about well, this is section 3.5, and it's on parallel and perpendicular lines, equations of parallel and perpendicular lines. So, first of all, parallel lines. What do you know? What have we talked about already? What do you remember? If two lines are parallel, wait, say it louder.
They never cross.
They never intersect. That's correct.
They're on the same plane.
They're on the same plane. They have to be on the same plane, right? They can't be on two different planes and be parallel, can they? So I can't have one like this These two lines never intersect, but they're not parallel, are they? Do you remember what the name for that is, by the way?
Skew.
Skew, that's right, skew lines. These two lines are skew lines. So two lines in the same plane that don't intersect or are always equidistant from one another. They're parallel. What do you remember about the equation of the line? If two lines are the slopes. The slopes have the same value, don't they? They're both, in this case, maybe going down 1/2, something like that. So two lines. Now, if they're in slope-intercept form, we can tell they're parallel, can't we? That is not an issue at all. We know that these two lines are parallel, no question about it. You can see the slopes, and there you go. If they're in standard form, or if one of them is in standard form, then it could get a little more dicey, couldn't it? So if I had something like 2x plus 3y equals 5, and then y equals, I don't know, -2/3 x plus 6, and I ask you if those two were parallel to one another, she's just got a little more binding now, didn't it? What do you think? Parallel or not?
Yes, it's parallel.
I see some slight noddings and one answer. Good job, everyone. You guys aren't going to talk no matter what, are you? I'll bring candy. I'll bring candy and bribe you with candy. Okay. So we're thinking maybe they are. If we take this one and we solve for y, you ready? Subtract 2x from both sides. Divide every term on both sides of the equation by 3. Okay, so that we have 1y right there. And then we see that the slope's -2/3. And so they are, in fact, parallel, aren't they? Okay? Okay. What if you're looking at a graph? So, for example, page 157. Want to look at that? Right in the middle of page 157, example 2, there are some lines there, and the blue one and the red one and the green one look like they might be parallel. What do you guys think? I hear the red and the green. You guys agreeing with that?
Yeah.
Both. What is the slope of the red line and the green line? 1/2. Now the blue one's close, isn't it? But it slopes 1/3, so it's not quite parallel, is it? So don't just look at the pictures and say, oh, they look parallel. Make sure that you actually, figure out what the slopes are in case they're close. Now let's talk about perpendicular lines. Two lines are perpendicular if they're in the same plane and they intersect and form a right angle. Like this. Right angle right there. How can we know, looking at the equation of two lines, if they're perpendicular?
Their slopes would be opposite.
It would be opposite reciprocal.
Opposite reciprocal. So like 1/2 x subtract 1, and the other one would have to be -2 x, maybe subtract 4. Now I just did, on example 2, I just wrote the equation of the red line. It slopes 1/2 and its y-intercept is -1, correct? You guys can see that from the graph. And then I did the equation of the purple line. Its slope is -2 and its y-intercept is -4. And so here we have two lines and their slopes. They're not just reciprocals, are they? And I hate this because whenever we talk about this, someone always gets confused about reciprocals. Okay, so let's make sure we're clear on this. What's the reciprocal of 4/5? And what do you get when you multiply a number by its reciprocal? Positive 1. Not just 1, positive 1, right? Even if the number is negative, okay, so I have negative 1/3. What is its reciprocal? Negative 3 over 1. And when you multiply them together, what do you get? Positive 1. Okay, so any number times its reciprocal is positive 1. Here, we're not just talking about the reciprocal, we're talking about opposite reciprocals. If you just do the reciprocal, those two lines aren't parallel, or excuse me, perpendicular. Remember we graphed some last week? We took a look at them, didn't we? So make sure that you think opposite reciprocal. So let me ask you this. If the red line and the green line are parallel, and the purple line is perpendicular to the red line, does it have to be perpendicular to the green line? It has to, doesn't it? Okay, so if it's perpendicular to one of two parallel lines, then it's perpendicular to both of them. That sounds like a theorem. Yeah? If a line is perpendicular to one of two parallel lines, then it's perpendicular to both. That's something we've got to remember. Okay, writing the equation of parallel lines. So you're going to be given a problem something like this. I want a line to have this slope, and I want it to be parallel to this line. Okay, so I've just told you. No, well, gosh, that can't work. Can I have this slope and be parallel to this line? No. That can't happen, can it? That's not what I meant to say. Man, it's been a long weekend. I want it to go through this point. Sorry. Let's say 4, 1. I want it to go through this point, and I want it to be parallel to this line. All right, now we're in business. Okay, so what have I just told you? I want it to go through this point, and when I say it's parallel to this line, that's just a sneaky way of saying, yeah, here's the slope. I want its slope to be 8. So I don't care about the rest of the line. I don't care about the y-intercept here or anything like that. When I say I want it to be parallel to this line, that's just a sneaky way of saying, here's the slope that we want it to have, right? So if I have a point and a slope, how am I going to write the equation? Point slope form. That's right. If we have a point and a slope, we're going to use point slope form to write the equation. If you forget point slope form, I think we wrote it in your notebook, didn't we? Didn't we write it in the cover of the notebook one day? It's also on the poster up here, the yellow poster aligned by all its names. Okay, so let's do this. Y subtract the y value of our point, which is 1, equals the slope times x subtract the x value of our point, which is 4. A little confusing because, you know, here you got the y and the x, and then over here we got x and y. They're kind of backwards, aren't they? Make sure you get them in the right place. So this is the equation of the line that is parallel to this line and has the given slope, or yeah, parallel to this line and goes through this point. Not quite the form we want eventually, but at least it's the equation, isn't it? And can we take it from this form and change it to slope-intercept form? Could we change it to standard form? Could we change it to double intercept form? Yeah, we could change it to any form we like, but usually we like slope-intercept form. So remember, it's always eliminate the variable or the parentheses whenever we're solving an equation. Even if it has two variables, we're going to eliminate parentheses first. And then we're going to add like terms. And then if we're solving for y, if we have y's on both sides of the equal sign, we're always going to get rid of one of them. We don't want y's on both sides of the equal sign. And then we don't want any constants with the y, so we just want the y by its lonesome, so we're just going to add 1 to both sides. And there you have it. There's the line that we're looking for. Okay, so I want you guys to try one. And I'm going to put some negative points in to make things a little more interesting. So let's say, let's make it go through this point, and let's make it parallel to this line. Oh. So figure out your y-intercept and your slope, or your point-intercept. Do point-slope form and then get it into slope-intercept form. Watch the signs.
Almost done. I'm gonna go. I have to go make copies. What is that down like that?
Oh, okay. I got a little bit of my printer. Thanks, man. Okay, can we take a look? So we've got a point and we've got a slope, and we don't care about the rest of this, do we? All we care about is that's what the slope needs to be. So y subtract 2, that's our y value of our point, equals our slope, which is 1/3, times x subtract our x value, which is -3. And if you're going to mess up, that's probably where it is, right? You're not going to get the double negative. This becomes +3 then. And then when we solve an equation, remember, it's always eliminate the parentheses. Now I saw a few of you get a calculator out. I'm a little disappointed, I got to say. 1/3 times x? Yeah. 1/3 of 3? That's 3/3, which is 1, isn't it? Okay. And then most of the other steps in solving an equation we don't have to do. We don't need to add like terms here. We don't have y's on both sides of the equal sign. We do have a constant we need to move over, so we're just going to move that constant over. And y equals 1/3 x plus 3. And there we have it. Okay? How'd you do? Good? Yeah? Now, what if we change things up a little bit? Okay, so this time I say I want it to go through this point, but I want it to be perpendicular to a particular line. Let's say y equals, I don't think it's really going to matter, so we'll just go 3. Ooh, that would matter. I don't want to make this too terrible. let's go 2. 2x subtract 5. So again, see how I'm giving you a point. I'm saying I want it to go through this point. And when I say it's perpendicular to this line, what am I really saying? Hey, stop. You guys are already doing it. Yeah, I know you're a step ahead of me. What am I really saying when I say it's perpendicular to this line?
That was slope for the other one.
Yeah, that the slope is, there you go. You guys already had it and you were already doing the equation. Okay, do this equation. How's the point slope thing working out for you? Are you still mad at me about making you do it that way instead of just find the y-intercept and write the equation later? Carly, you forgive me yet? No? Okay, watch those signs. Watch the signs as you plug them in, and then also you're going to have to multiply by a negative number, so watch that. Okay. How'd you do?
Good.
Did you guys put plus 0? You just let it be the ghost 0 since it's Halloweeny. Okay, so that's fine. Doesn't really matter. Okay. Oh, now ready for the hard one? So. I've got a point here, and I've got a line, and I want to know the distance from this point to that line. Now you guys know how to find the distance, kind of, don't you? What have we talked about with distance before? Distance formula, right? But is the distance formula for a point and a line? What's it for? 2 points, right? Okay. So here's kind of the situation here. So this equation, I suppose it would look something like this. And then we have this line, or excuse me, this point right here, 1, 0, which is, over here someplace. So what do you guys think? Is this the distance from the point to the line? How about if we went straight over like that? Would that be a distance? How about this one? How about this one? How about this one? Where is it? So it has to be right there, doesn't it? We've got to find this point on the line that when you connect it with this point, it gives us a perpendicular segment. And then we need to find the length of that particular segment. So we need to find that shortest distance, don't we? And this is the shortest distance from the point to the line, isn't it? Are you sure? If you choose any of the other lines Okay, if you look at any of the other ones, say for example we choose this one, do you see how that forms a right triangle? Everyone agree? So we have this right triangle, and isn't this side the hypotenuse of the right triangle? And what do you guys know about the hypotenuse of the right triangle compared to the leg of a right triangle? It's longer. Yeah, the hypotenuse of a right triangle is the longest side, isn't it? So that's what we got. So we need to find that point right there. Somewhere along this line, we need to find that point that gives us this perpendicular segment. And then we can use the distance formula to find the distance between our 2 points. Okay? So how are we going to do that? Well, if I have one equation, I have the equation of this line, this down 1 over 1 kind of line here. It's not quite right, but it'll work. I need the equation of the line that's this line that's perpendicular. And it needs to go through this point right here. Now we can do that, can't we? Can't we find the equation of the line that's perpendicular to this one and goes through this point? So it's got to go through this point, and it's got to be perpendicular to this line. So what does its slope have to be? Eh?
Negative 1?
-1?
1.
1?
Positive 1.
Positive 1. It's got to be the opposite reciprocal, right? Okay, so we're going to find the equation of the line that goes through this point and has this slope right here. So y subtract the y value equals the slope, equals the slope times x subtract the x value. Ooh, this is kind of easy. Y subtract 0, that's nothing to worry about, equals 1 times x, subtract 1 times 1. Okay, so there it is. There's the equation of this perpendicular line, right? Now, here's the thing though, I've got this line, that's here. I've got this line, that's here. How do I figure out that point?
Guess you could solve both of the equations as a triangle.
Yeah, where the two equations cross, isn't that the solution to the system of equations? So if we look at the equations like this, as a system of equations, that intersection, this point right here, okay, that point right there is the solution to this system, isn't it? Now you could do it by graphing, and I think in this case they're super simple. We could probably graph them and see the point that they intersect, especially if that point is nice whole numbers, if x and y are both whole numbers. Now if the solution was like negative 523 and 2.6, that'd be a little tougher, wouldn't it? Right? But we could solve by graphing them. But I think we could solve by, probably better if we solve by substitution or elimination. What do you want to do here? Substitution or elimination? Substitution? Well, since they both of these things equal y, this equals y, this equals y, I'm going to say that the opposite of x plus 3 must equal x subtract 1. Agreed? So let's see. I'm going to add x to both sides. And then I'm going to add 1 to both sides. And then, move my paper up, I'm going to divide both sides by 2. And x equals 2. Okay, so that's the x coordinate of the point. So this point right here, its x coordinate's got to be 2. What about its y coordinate? If x is a 2, what's y? Yeah, it's a 1. Let's see, does it work here too? If we put a 2 right there for x, is y still equal to 1? Okay, so now we've got this point, and we know this point. Can we find the distance between 2 points? So the distance between the 2 points equals the square root of x, I'm going to start with this point, x subtract the other x value squared plus y subtract the other y value squared. So distance formula, this is the Pythagorean theorem. So 1 subtract 2. Now remember, this is in parentheses, negative 1 squared. And then this one is in parentheses, negative 1 squared. And negative 1 squared, 1 plus, that's root 2, isn't it? Root 2 is a dang awesome special number. We need to take a little bit of time and talk about it. But yeah, it's root 2. So we just have this triangle there. So there you go. The distance between the point and the line is the square root of 2. And just to point something out, what kind of number is the square root of 2? Root 2. Is it real? Yep, it's real. It's not fake. It's not imaginary. It's real. It's on the number line, right? It's a real number. Irrational. So that means it's a non-repeating, non-terminating decimal. So it's something like 1.4142 blah 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 blah. I don't know the rest of it. I can't write it. I can't write the square root of 2. Why not? Yeah, it never ends. I'd be here forever, wouldn't I? Okay? I know that's how you guys feel right now. I've been in Mr. Collar's class forever. It's only first day of the week, first period. Okay, we can't write it, but I can draw it. Do you believe me? I can draw the square root of 2. How can I draw it? If I can't write it, how can I draw it? See that red line right there? What is it? That's odd. We can't write the square root of 2, but we can draw the square root of 2. 1 squared plus 1 squared equals 2 squared, right? That's weird. Well, here you go.